Hey y'all, we are going to complete the square. So this is still talking about quadratic functions and the fact that they have many different solutions, and it usually is based on what the function actually looks like. I know so far we've done the factoring and the square root property, and now we're going to do completing the square, and we're also going to do the quadratic formula. All of those leading terms are going to be squared. It's like x squared, y squared, z squared, whatever variable they decide to show you. For completing the square, the formula that we have is a squared plus or minus 2ab plus b squared equals a plus or minus b squared. So these right here in my formula, it's to account for if all of our signs are positive or if that first sign on my 2ab is negative. And whenever we actually get it into our binomial form at the end, those signs will match, okay? So if x squared plus bx is a binomial, then by adding in parentheses, we have b over 2, and then it's all being squared. And that is actually the square of half of the coefficient of x. So if x squared plus bx is a binomial, and we add the square of half of the coefficient of x, a perfect square trinomial will result. So our formula down here at the bottom, this right here, that is a perfect square trinomial. And if you notice, it has the x squared plus bx on the left. That's what we started with. And so what we're saying is if we take that coefficient, that's our b, we cut it in half, and then we square it, what will happen is we will be able to write it in this way. So let's go ahead and solve it. I think it'll make a lot more sense once we actually get into the problem. So for a, we have x squared plus 8x. Now, I know that I'm looking at a formula, and I'm going to need to know a certain amount of things to be able to plug into the formula. And what I need to know is my b term, which is the coefficient attached to the variable that's not squared. So my b is 8. And then when I look at my formula, I also know that I'm going to need to know what half of my b is, which is 8 divided by 2, which is 4. And then I'm also going to need to know what half of my b squared is. Well, my half of b is 4, and if I square it, I get 16. So those are the three things that I need to know. Now, what we're going to do is actually plug it into the form that I've highlighted in green, and we're also going to finish it with the right-hand side that I squared in blue. So what we have is x squared, and then it tells me to do plus bx, which is my plus 8x. Then it tells me to add to that half of b squared. My half of b squared is 16. And then we do equal. And what we get on the right-hand side in parentheses is our x plus half of our b, which is our 4, and you square it. So that's it right there. This is saying that if we square this binomial, what we get is this trinomial. And the fact that we could use this method means that it is a perfect square trinomial. That's what this left-hand side is called, a perfect square trinomial. Okay, so I'm going to do x squared minus 7x. So I know that I need to know what my b is, and my b is negative 7. I need to know what half of my b is, which is negative 7 halves, and I need to know what half of my b is squared. Well, if you actually square this right here, that's using an exponent rule, which states it's basically a power rule, and what happens is everything that is inside of those parentheses gets squared. So your negative 7 gets squared and your 2 gets squared. And we get 49/4. So now let's throw it in to the form that we need. We have x squared plus our bx, which is actually a negative 7x. And then we're going to add to that half of our b squared. And half of our b squared is 49/4 equals parenthesis x. Add to that half of our b. It is a negative 7/2. And then you square all of it. So if you wanted to go back and actually FOIL this, what you would get is this. Okay? I'm just going to scoot on over here. Now let's do this one. For this example, what we have is x squared minus 6x plus 4. Now in the directions, it had said that if we had a binomial, this is a trinomial. This is not a binomial. And excuse me, that's supposed to be equal to 0. Equal 0. What we have here is a trinomial, not a binomial. But what I want to do is actually solve this by completing the square. So it means that I need to turn it into a binomial. And the way I do that, by isolating the binomial on one hand side, I would be moving that constant to the left hand side. So I have x squared negative 6x equals a negative 4. Okay, so what we're going to do is identify our b, half of b, and half of b squared. I know where this is going, so I'm going to scoot this over. Okay, y'all? Now, let's identify our b is a negative 6. Our half of b would be negative 6 divided by 2. 6 divided by 2 is 3. Signs are different, so it's negative. And then half of b squared, well, half of my b is negative 3. So if I square negative 3, it's 3 times 3 is 9. Signs are the same. It's positive. So it told me that if I have the binomial and I add half of b squared. So what I need to do is, I'm using purple, is add half of b squared to my binomial, correct? Now, whatever you do to one side, you have to do to the other side. Remember, in the previous examples, all we had was the binomial. In this example, we're starting with a trinomial. So that's why it's going to be a little different. Okay, so I know that in the directions, it said that if I have the ability to write it like this, it is equivalent to this form right here. So technically, if I have the left-hand side, I can change it. I can write it, rewrite it. I can show it in a different way, right? And that's actually what you're going to do for the C problem. I now have a perfect square trinomial because I added half of my b squared to my binomial. And I know for a fact that I can rewrite it using this form right here, which would be, we add to it half of our b squared. That is because x squared negative 6x and a positive 9 is the same thing. It equals x minus 3 all squared. So I'm using the facts I learned in those first two examples to rewrite this perfect square trinomial, right? Now on my right-hand side, what I have is a negative 4 and a positive 9. Signs are different, so you subtract and you keep the sign of the larger. Now what I would do here is the square root property because I'm solving for x. So if I take the square root of the left-hand side, I have to take the square root of the right-hand side, being sure to add my plus or minus. And then what happens is I am left with x minus 3 equals plus or minus the square root of 5. And then I'm solving for my x, which means I need to move my 3. So I have x equals 3 plus or minus the square root of 5. Okay, so that is your final answer right there. The reason why this one was different was because it had started out as a trinomial and it was set equal to 0. And if it's ever set equal to 0, what we're doing is actually like solving for the numerical value of our variable, our x. Of course, we would use the square root property because I've got an x squared and I'm not trying to solve for the value of x squared. I'm trying to solve for the value of x. So I needed to use the inverse. And then I added my plus 9, positive 9, to both sides because of the addition property of equality, which just states that if you add something to one side and you add something to the other, mathematically you haven't changed the equation. You just have to make sure you look at it as a balancing game. So I had my binomial, I figured out all of my parts, I added half of my b. What I did to one side I had to do to the other. I rewrote this because I know those forms are equivalent, and then I did the square root property to solve for my variable. And that is how you complete the square. Okay, thanks. If y'all have questions, make sure y'all let me know, okay? Bye.